Okay, so this is ASA and CPCTC congruence. The first thing we're going to talk about is ASA. ASA is when you have an angle, a side, and an angle. And in this case, the side is included. Again, when I say it's included, I mean it's in the middle. So here are the two angles that they're giving me. They're giving me this angle and this angle. You notice that the side that they gave me is in fact stuck in the middle of the two angles. Here's what I mean. Here's the first angle, the second angle, and the side is stuck in between, okay? If they would have given you this side, then you have the angle. Notice that the side is not between the two angles. Or if they would have given me this side, again, you have your angle, and you notice that the side is not in between the two angles. If it was, it would be right here, okay? So angle side angles when you have two angles and the side is stuck in between. Next thing we're going to jump into is alternate interior angles. This is another thing that we've talked about before. Alternate interior angles are when you have a set of angles that are in between the parallel lines and on opposite sides of the transversal. The easier way that we've said it, let's see, in between the parallel lines, opposite sides of the transversal, we said it looks like a Z, right? And on that Z, it catches the two angles. It catches those little angles on the top. We'll go ahead and draw that picture in here as well. You need to have parallel lines in order for this to work. Okay, so you have the two parallel lines and then this transversal cutting across, and it's looking like a Z. And when you do that Z, you're going to get this, it's going to catch those angles. Alternate interior angles are congruent. So whatever this angle is here, I can say it's equal to this angle over here. Put a little side note down there. To find alternate interior angles, just look for the Z's, and you should be good, okay? All right, so let's show some examples because there's going to be times when you'll be able to find a Z. There's going to be times when you find multiple Z's. So first and foremost, very important that when you find these Z's, you use the parallel lines. So that should be the top and bottom of your Z. Here's the parallel lines, and here is the line connecting those parallel lines, and I make a Z like this. Like this. Now what's going to end up happening is students are going to see other Z's as well. They're going to see this one. They're going to go, oh, okay, well, I have this line and I have this line, and then I'm making a Z like this. The problem with that line is you're not using the parallel lines. You can't make Z's unless you have parallel lines. So you can't use these two lines because there's nothing indicating that they're parallel. So you can't make the Z with that line. I hope that's making sense. Okay, when you're using parallel lines, when you're making Z's, you have to make sure that you have the parallel lines. And when you do that, you get those two angles there. On the next one, same thing. I'm going to go ahead and use the parallel lines, and I'm going to make the exact same Z I did before. So I'm going to get this like this, and I catch these angles in here. I know those angles are congruent. I can also make a different Z. I'm still going to use those parallel lines. Remember, you have to use the parallel lines if you're going to make a Z. But instead of using the first transversal, I'm going to use the second transversal. And now I'm catching these angles here. This angle must be congruent to that angle over there. So now I have two sets of congruent angles, and I have an A and another A established. All right, so that takes care of the review. Let's go ahead and jump into a few proofs. The first proof is going to start with the statement WX is parallel to ZY. Prove that triangle ZWY is congruent to triangle XYW. Okay, so from the statement, I don't think I was supposed to give you these, but I accidentally did. It doesn't matter though. You're either going to get them from here or you're going to get them from the picture. Regardless, they're telling you those lines are parallel. And so I can go ahead and write my given. I know for a fact that segment WX is in fact parallel to segment ZY. And I knew that because they gave it to me in the picture, they gave it to me in the word problem, and so it's definitely given. Okay, so now I know that those two lines are parallel. The other thing that I definitely know from the picture is that they gave me these angles. Look, check that out right there. They're telling me those angles are congruent. That's not a guess. That's not, it looks like I know for a fact because they're flat out telling me right here. Now you can't call this angle W because there's a couple of angle W's, so I'm gonna have to use three letters. I'm going to go ahead and call this angle ZWY. And that is congruent. I need to do the exact same thing. So since I started at this corner, went up and then across like this, I need to start at the corner, go down and across like this. So it's going to be angle XYW. How did I know that? Well, that was given in the picture. And when I do this one, this does in fact give me an angle. So let me go ahead and write that. I got a little A right there. All right, if you're given parallel lines, chances are you're going to try to make those Z's. All right, so that's exactly what we're going to do right now. And remember, you have to use the parallel lines when making your Z. So I'm going to use this line, and I'm going to use this line, and I do see a Z popping up. That means I'm getting a Z right here. And that means I'm going to catch these angles, this angle and this angle over here. I do have congruent angles because of the Z. So let's go ahead and write down what those angles are. This first one is going to be angle ZYW. ZYW went from the corner to the green to the yellow. Angle ZYW is congruent. And I'm going to do the same thing. So I'm going to start from the corner to the green to the yellow. That's going to be angle XWY. I'm sorry. Angle XWY. That was not given. That was something that I had to figure out. The reason I did it was because of the Z's. I can't say that the reason is the Z. Remember that Z's are alternate interior angles. So the reason these are congruent is because they are alternate interior angles. And now that I have that these angles are congruent, that gives me another angle. And then lastly, I have two triangles being squished together. And when I have two triangles being squished together, that means one of the sides must be congruent to itself. I'm talking about this side congruent to this side. Now, hopefully you notice how I drew that. Because they're on two different sides of the triangle, I'm going to call this side right here going from W to Y. Notice that on this side, I went from the yellow to the green. I'm going to say segment WY is congruent. WY, yellow to green. I'm going to do the same thing, yellow to green. That's going to be YW. So in this case, the sides actually, the letters do switch, okay? And when you say something is congruent to itself, that's giving me this thing right here. When you say something is congruent to itself, we say that that is reflexive property. When I get reset reflexive property, I get an S. Notice that I have the two angles. And the side is in fact in the middle of those two angles. So this is enough to say that the triangles are congruent. Since the triangles are congruent, I'm going to write exactly what I wanted to prove. I know for a fact that the triangle ZWY is in fact congruent to triangle XYW. Triangle ZWY is congruent to triangle XYW. And the reason I know that is because of angle side angle. And that finishes out that proof, okay? Now, remember what it means for triangles to be congruent. That means it's the exact same triangle, right? So it's just in a different spot. Going back to the Dorito example, it's the exact same Dorito. So it doesn't matter if you have the Dorito on the bottom or the Dorito on the top. They're the exact same thing. That means all their sides are going to be matching up exactly the same. All the angles are going to be matching up exactly the same. All right, go ahead and flip your paper back to the back side. We're going to be using something that's very fun to say. Students love saying it, but it does take a while to kind of get used to. And that is CPCTC. And you're going to go, what did he just say? CPCTC. It's an acronym for corresponding parts of congruent triangles are congruent. That's what the CPCTC stands for. Now, what that's trying to say is if you have two congruent triangles, then their parts must be congruent. Kind of like saying, oh, I can match up the individual pieces. All right. This is going to be very, very important when they're asking you not to prove that the triangles are congruent, but rather to prove like, oh, two angles are congruent. or two sides are congruent, what you do first is you prove first that the triangles are congruent. Therefore, you have the exact same Dorito in each hand. And since you have this exact same Dorito in each hand, then you can say, oh, then these two pieces of the Dorito or these two pieces of the triangle must in fact be the same because the triangles are the same. Okay. So let's show you how this works. In this case, they're telling you that triangle QRS is congruent to triangle RQT. Now, normally I would say, hey, go ahead and match up your letters. And I would say, oh, the first letter matches up with the first letter, so Q matches up with R. The problem with this one is that in the very next statement, then R matches up with Q. So I just said that Q and R match up in green, and then I said that R and Q match up in pink. And so when you start highlighting the Q's, you're going to highlight the Q in green, and then you're going to highlight the Q in pink. And that's going to make it really, really confusing. And the reason is because these triangles kind of swap places with each other. Okay, so I'm not going to do it. Well, no, actually, this one is still going to work. But it is going to be confusing as it relates to color coding. Let me show you what I mean. I said that the Q, the green Q matches up with the green R. So if I start highlighting it like this, right, like you get that. And then the next statement I said was that the pink R matches up with the the pink R matches up with the pink Q. So now R and Q have two different colors. And the reason why that's happening is because they're saying that this triangle that starts here and goes like this is the same triangle that starts here and goes like this. So they kind of flipped it on itself. And now that R and that Q is getting used up twice, okay? However, it's not going to matter for this problem just because they do match up T with S in yellow, and that's the only thing I'm really going to need because I'm going to try to solve for A. Hey, these two triangles are congruent. This triangle right here is congruent to this triangle right here. I want to solve for A. Well, since the triangles are congruent, I know their parts are congruent. That's what CPCTC stands for. Corresponding parts of congruent triangles are congruent. So because these two match up with each other, then I can say that this angle is in fact the exact same thing as this angle, and I can say that A is equal to 40 degrees. And we're done with that one. I was able to solve for A. Okay, let's try the next one. The next one's going to be a little bit cleaner. I can match them up just like I did before. I know that the first letter matches up with the first letter because they already told me that. So P matches up with M. I know that the second letter matches up with the second letter, so Q matches up with N. And I know that the third letter matches up with the third letter, therefore R matches up with R. So when I'm looking at this triangle, I should be like, oh, okay, this is PQR in that order is the exact same thing as M and R in that order. Okay, how are we going to do this? I want to solve for X. Yeah, it's kind of weird because over here I'm missing two angles, right? I'm missing the X and I'm missing this one. And over here, I'm missing two angles as well. I'm missing this one and I'm missing this one. So luckily, because I know these triangles are congruent, I know their parts are congruent, which means since this green angle is 90 degrees, that means this green angle is 90 degrees. So I can put a right angle right there, or you can write 90 degrees. Either one, it's the same thing. And now, when you look at the triangle on the right, you're not missing two things, you're just missing one. I got 90 degrees, I got 35, and I don't know this one. So let's go ahead and find that one. I'm going to call it a question mark. I know because it's a triangle, I get to write 35 plus 90 plus question mark equals 180. That means 125 plus question mark equals 180. Subtract 125 from each side and you get that question mark equals 55. And it's a bow tie. And on bow tie problems, I know I always have vertical angles. And that means since this is 55 degrees, this is 55 degrees because vertical angles are congruent, which means I was able to solve for that X. So we use the fact that we have congruent triangles to say that their parts must be congruent. Since their parts were congruent, then I know I can move that 90 degrees over to its partner on the other side, okay? All right, so let's go ahead and do our first proof that involves CPCTC. They told us that segment RT is congruent to segment RV. and they told us that TS is congruent to segment VS. Look where it changes. Now they're asking me to prove that angle RST is congruent to angle RSV. Angle RST is this one, and they want me to prove that it's congruent to this angle down here. Now that's going to be really hard to prove without CPCTC, because notice, like, we don't have anything about angles in these ones. So the game plan here is, all right, if I can prove that the triangle on the top is in fact the same as the triangle on the bottom, then I know that their angles have to be the same, and then I can say that. All right, so that's the game plan. So even though they're asking me to prove that the angles are congruent, I'm actually first going to prove that the triangles are congruent. That way I can say their parts are. So let's see how this is going to work. Same thing, same setup as always. I'm going to look at my picture and I'm going to say, is there anything that I saw from my picture that they told me? Absolutely not. There's no information that they flat out told me on this one. Next thing I'm going to do is there anything that they told me in the word problem? Absolutely. They told me that segment RT is congruent to segment RV. So let me go ahead and write that first. I know that segment RT is congruent to segment RV. That's this segment is congruent to this segment. How did I know that? Well, they told me in the picture. So I'm sorry, they told me in the problem. So I get to say that that was given. And when that's given, that actually gives me a side. Is that enough to say that the triangles are congruent? Nope, not yet. So we're going to keep on going. They also told me that TS is congruent to VS. So let me go ahead and write that. TS is congruent to segment VS. How did I know that TS is congruent to VS? Well, they told me that one too. So I get to write that that one was given as well. That means they gave me another side. Is that enough to say that the triangles are congruent? Nope, that's not enough. Remember, triangles are congruent. You need three things, right? It's SSS, SAS, AAS, ASA, and HL. But this is definitely not going to be HL because I don't see it at 90 degrees. So this is not enough. And there's nothing else that they really told me. So what I do have, though, is I have two triangles being squished together. And if two triangles are being squished together, then that means this side must be congruent to itself. On the top, I'm going to go from the yellow line to the pink line, which means on the bottom, I better go from the yellow line to the pink line, which means I'm going to say RS is congruent to RS. Segment RS on the top triangle is congruent to segment RS on the bottom triangle because they're the exact same size. I mean, it's the exact same side. It's got to be the exact same size, right? That gives me a third S, which means now I have side, side, side. Whoop. Got ahead of myself. I knew this is true because it's congruent to itself. So this is reflexive property. Trying to get a little too fast on you guys. Sorry for that. Reflexive property is when you say something is congruent to itself. Now I can say that the triangles are congruent. You need to write this in the correct order. So I don't care where you start on the top triangle. You just got to be consistent. So for example, what I mean by that is I'm going to start at R and I'm going to go yellow, pink, green. I need to do the exact same thing on the bottom. I need to go yellow, pink, green. So from R, I'm going to go yellow, pink, green. And that's how I'm going to label these. So I have to write, there's this one you have to kind of figure out on your own. Triangle RTS, yellow, pink, green, is congruent to triangle, again, yellow, pink, green. That's going to be RVS. How did I know that? Well, I know they're congruent by side, side, side. Guys, the triangles are congruent. Since the triangles are congruent, that we're not done because again, they didn't ask us to prove that the triangles are congruent. They asked us to prove that the angles are congruent. But because the triangles are congruent, now I know that their parts must be congruent, which means this angle RST right here needs to be the exact same thing as this angle RSV down here because they're congruent triangles, so their parts must be congruent. So finally, I can go ahead and write what I wanted to say. I know that angle RST must be congruent to angle RSV. How did I know that? Well, because they're congruent triangles, and congruent corresponding parts of congruent triangles are congruent, which means I get to write that this is true because CPCTC. Since the triangles are congruent, then their pieces must be congruent. Therefore, I can say those two little angles must be the same. All right, guys, we are down to our last proof. I know this video is a little bit longer. Sorry for that. I'm trying to run through it as quickly as possible. It says angle JKL and angle MLK are right. They're also telling me that segment JL is congruent to segment MK. I need to prove that segment JK is congruent to segment ML. I want to prove that this side is congruent to this side. Now, obviously, they look like they're congruent, but that's not enough, right? We have to verify that that is, in fact, the case. So in the picture, is there anything they told me in the picture? I don't see anything in that picture that they flat out told me, right? Like I see certain properties that I might be able to use, but nothing as of this is what they flat out told me. In the problem, they did tell me this. They told me that angle JKL and angle MLK are right. So let me go ahead and write that. Angle JKL and angle MLK are right. That means I can go ahead and sneak this in right here and sneak this in right here. And this one was given. Okay, so I have a right angle over there. Perfect. They also told me that segment JL is congruent to segment MK. JL is this long segment here, and MK is this long segment here. I'm going to do this a little weird. I don't normally write it like this, but just because it's kind of weird to see, I'm going to go ahead and do this. But not only am I going to highlight the two tick marks, but I'm going to highlight the whole side just so you understand. It's like this is the whole side here, matches it with this whole side here, okay? And that gives me a side. So I get to write segment JL is congruent to segment MK. And I know this because it was given. Okay, this is going to be a weird one. And so I did put a double space there. And this is just because I kind of know where this theorem is going. Guys, you see how this is a right triangle right here? Because of that 90 degrees. And you see how this is a right triangle right here? Because of that 90 degrees. I know it's weird, but in proofs, you have to establish that those are right triangles. So I'm going to flat out write that those are right triangles. I'm going to say triangle JKL and triangle MLK are right triangles. How do I know they're right triangles? It has that 90 degrees, right? You can't write it has that 90 degrees. You're going to have to say definition of right triangles. Guys, if I'm doing this, if I'm saying like, hey, look, it's a right triangle, then that S that we're looking at, it's really not an S. Here is the right triangle. This side right here, it's not touching the 90 degrees, so that S is actually an H. It's a hypotenuse, okay? So I think you kind of know where this proof is going now. The only thing is, since I have a hypotenuse, I got to check out, well, do I have a leg? This side and this side? Nope. Ooh, what about this side with this side? You see how those triangles are kind of smushed together? They're smushed together, but they're using the same base. They both have the bottom part. So I'm going to say KL. Oh, I got to be careful. Let's see, on this triangle, when I did the bottom side, I need to go from the 90 degrees to the corner. That means on the other triangle, I need to go from the 90 degrees to the corner. It looks like the direction switched. The first one went this way. The second one went this way. So I'm going to say segment KL is congruent to segment LK. And it is the exact same segment, so we say that that's reflexive property. Guys, doesn't matter if you're looking at the first triangle or the second triangle, both of those sides are touching the 90 degrees, which means that this is going to be a leg. And because you have a hypotenuse and you have